Okay. We're going to go ahead and talk about weather patterns right now. So, there we go. Uh-oh, warm front is coming through. What? Okay, so the secret to weather is that warm air rises because it's less dense. Remember we said warm air has molecules moving a lot faster, and when they move faster they bump into each other and spray each other everywhere, and so warm air is less dense, so it will rise. Cool air is more dense because the molecules don't move as fast, so they don't bump into each other, so they're able to be closer together, and when you have more stuff in a certain area it is more dense. So cool air sinks, warm air rises. So air pressure, this is kind of a review from our layers of the atmosphere stuff, but the weight, air pressure is the weight of a column of air pushing down on an area. We know that more dense air has higher pressure. That means more of the molecules want to escape, the more dense it is. And less dense air have less molecules, so there is less pressure. Air pressure is measured by an instrument called a barometer in inches of mercury, or actually millimeters of mercury in science. In weather, air pressure impacts how weather happens, and we either see things called high pressure systems or low pressure systems. So a high pressure system, I'm going over here. Okay, high pressure systems are large bodies of circulating air with high pressure or high density. And its center and low pressure, at its center and lower pressure outside the system. So that means it is very high density in the middle of it, and it typically brings sunshine and good weather. It's represented by a blue H, and typically it's cold air that is sunk towards the Earth's surface, leaving nothing above it, thus no clouds so you can see the sun. But that sounds a little bit confusing, right? Because I said that it is cold air, but yet it brings sunshine and good weather. So I understand that's a little confusing, so we have this. So here is the very dense air right here, okay? Up here, there's a very dense air, and as you go, it is moving down because high dense things sink, okay? So cold air is sinking because it is high density, and you notice that the H is right there. You also notice that the molecules are going like this, okay? Because the molecules are moving like this, if you remember how we talked about convection, well, as cold air sinks, it will be warmed by the Earth's surface, and it will go back into the atmosphere where it cools down, and then it will sink again, so you'll get these convection cells. So high pressure, essentially, there's nothing left above. So once the high dense cold air falls, there's nothing left in the atmosphere. So there it is, nothing left there. So that means because there's nothing left there, no clouds can form. And when no clouds can form, you get good weather because the sun can get through and can heat. And so therefore you're going to get better weather. So the next one is our low pressure systems. And low pressure systems are large bodies of circulating air, remember convection, with low pressure at its center. That means that there isn't a lot of molecules around it, and it is higher pressure outside the system. This typically brings clouds and precipitation. It's represented by a red L. And the reason why is that it is warm air. It's red because it is warm air. And we're going to go ahead and look at that animation really quick. So when it is less dense air, warm air, remember warm air rises. And when warm air rises, it's going to move into this part of the atmosphere that's a lot colder. And when it's a lot colder, it's going to cause the water vapor in the air to condense. And when it condenses, it forms clouds. So the clouds are going to block out the sun, making it colder, and it's going to make it rain. Okay, rain or snow or some sort of precipitation. So that is what you see there. Let's look at that one more time. So the warm air is rising, less dense air into the sky, then it condenses because it's gotten cold. Okay, so it's moving up into the air because warm air rises, it's cooling off, and it's going to condense and clouds form, and now we get rain. So I hope that part made sense. Okay, so air masses. So large bodies of air with similar temperature and humidity and air pressure are called air masses. Air masses can form either over land or water, and they can also come from two different areas. They can come from the polar region, or they can come from the equatorial region or the tropical region. So air mass is warm or cold air, and it depends on the temperature over which the mass was formed. So the four types of air masses are tropical. This is warm air that was formed over the tropics. Polar air or cold air masses that formed over the poles, north or south. Maritime air. This air mass forms over the ocean, which means it's very humid. It has a lot of liquid in it because of evaporation, so a lot of water vapor has made it into this air mass. And continental. When it forms over the land, it has less water to access it, and so therefore it is very dry. So continental dry, maritime humid, polar cold, tropical warm. So we know continental means over the land, maritime means over water, polar means it's going to be cold, tropical means it's going to be warm. And here's a map. So essentially they can be two of each of these things. So if it's coming from the ocean and in the poles, it's going to be a maritime over the ocean, polar, cold air. So a humid, cold air mass is moving in. If it forms over the land on the poles, it's going to be a Arctic air mass, okay, or a continental, a continental Arctic or polar air mass. We have continental Arctic air masses. We have maritime polar. I guess I can move this really quick. We have maritime polar air masses. And then from the south, you'll notice we have maritime tropical air masses coming from the ocean. Coming from the continent, we have continental tropic air masses, meaning dry, warm air masses. And we have maritime tropical air masses coming from the ocean once again and moving upward. Okay, fronts. So this is the thing you hear weather people talk about all the time. So fronts are where air masses meet but don't mix. They don't mix because they're very different temperatures and very different densities. That means there's some high pressure, some low pressure, some warm, some cold, some are greatly dense and some are not so dense at all. And when those two things meet, you get a front. So there are four types of fronts. Okay, we have warm fronts, cold fronts, occluded fronts, and stationary fronts. Cold fronts. Okay, so cold fronts is when cold air mass is replacing a warmer air mass. So essentially, this is the direction that our air is moving. There it goes, there it goes, there it goes. And it is replacing, okay, the whole movement is this way. I don't know if you can see these arrows right now. All this air is replacing. Remember, cold air sinks, so it's sneaking underneath this warm air and it's forcing all this warm air up. Okay, so all the warm air is ending up on top of it, and this is called a cold front because the cold air is replacing the warm air. It's shown on a map by a blue line with triangles that show the direction that the cold air is moving. Okay, cold fronts typically move pretty quickly, and they happen when cold air masses runs into warm air masses. The denser cold air slides under the lighter warm air, pushing it upward. The rising air cools. So remember, when the warm air is forced upwards, it goes higher in the atmosphere, which means it's going to get colder. And when it gets colder, it's going to condense and form clouds. This is when you typically get a heavy rain or snowfall. If the warm air mass contains only a little water vapor, so if this is more of a continental polar front or air mass, then we typically won't get as much. It just may be cloudy skies with a little bit of chilliness to it. So the fronts. We've got the cold front, the zone where the cold air is replacing warmer air, like this. So we have cold, warm. So if you look on a map, you can see there's cold air, so 38, and then warmer temperatures on the other side, so we know that is a cold front. As the cold fronts move, the air typically gets drier because cold fronts tend to be drier because there is no condensing, so they stay pretty close to the surface. They move quickly and can cause abrupt weather changes, and cold fronts can cause the thunderstorms. So when we talk more about storms next week, you will hear more about thunderstorms. So after a cold front passes through, cool, dry air moves in. Clear skies and cooler temperatures often follow. So the clear skies happen once the warm front that the cold front displaced is gone as well. Warm fronts. Warm fronts collide with slower moving, cooler air masses, as you see here. So you have the movement right here. The warm air is being forced above the cold air, okay, which means it's starting to cool off. All right, if you notice, when warm fronts come through, warmer temperatures follow, colder temperatures happen before that. You can always tell the direction of the front by which side the little symbols are on. Warm fronts are shown by the little lines with the half circles on them. So the warm front is moving this way. It is shown on the circle by a red line with half circles pointing in the direction the air is moving. So moving warm air mass collides with slowly moving cold air masses. The warm air masses move over the denser cold air. If the warm air is humid, showers and light rain fall with the front where the warm and cold air meet. So in other words, when you looked right here and it was forced up, and you see the clouds are forming, you're going to get clouds and light rainfall, but you're also going to get an increase in temperature. So you rarely will get snow in that instance. If the warm air, don't know what happened there. If the warm air is dry, scattered clouds may form. So if there's no actual liquid in the warm front, they will. Okay. So warm front is where the warm air is replacing the colder air. Air gets more humid after warm front moves through. Typically, warm air has more humidity to it. Okay, warm fronts. Because warm fronts move more slowly than cold fronts, the weather may be rainy or foggy for several days after a warm front. But after the warm front passes, the weather is likely to be warm and probably humid. If it's in the winter, warm fronts typically bring snow. Comparing warm and cold fronts move faster than warm fronts. The weather activity in a cold front is often violent and happens directly at the front. Cold fronts have sudden gusty winds high in the air, creating turbulence. And weather activity in warm fronts generally happen before the front passes. In warm front, the cloud formation is very low, often creating situations of poor visibility. Occluded fronts. When warm front is trapped by two cold fronts, as shown here, cold air, and the warm air is forced up, shown by the weather map with a purple line and alternating triangles, right here, triangles and half circles. Occluded fronts is warm air masses caught between two cold air masses. The denser cool air masses move underneath the less dense warm air masses and it's pushed upwards. The temperature near the ground becomes cooler. The warm air is cut off from the ground and the warm air condenses, meaning the weather may turn cloudy, rainy, or snowy. We know that the occurrence usually results in storms over the area. In the US, the colder air usually lies to the west. Stationary fronts, so the front that stops moving or is moving very slowly. It is shown on the weather map with alternating red semicircles pointing away from the warm air and blue triangles pointing away from the cold air. So as you see here, warm air is here, cold is moving this way, cold is here, warm air is moving this way. Stationary fronts sometimes are cold and warm masses where they meet, and this is a standoff because neither is strong enough to move the other. Stationary fronts typically happen where water vapor in the air condenses into rain, snow, or clouds, and it stalls over the area, bringing days of clouds and precipitation. So when the front starts moving again, either returns to being a cold front or a warm front. All right, and that is pretty much it. If you can look right here, we can see we have an occluded front, cold front, warm front, cold front, and we have a stationary front down here. Cold, warm, okay. Okay, so think about this before we leave. If you're planning a trip to Alabama, the high temperature there is 68. There it is. What do you think the weather might be like tomorrow? Put that in your interactive notebook and we'll talk about it tomorrow. Thank you.